Okay, you want to know what unit vector? So this is how you find your unit vector. This is a formula you use to get your unit vector. It's gonna be vector v over the magnitude that you got. Okay, this is how you actually go and find the unit vector. And then the formula to get v vector, this is the one used if you work with 2D. This is a formula you can use. You can see we have vxi plus vyj. This is j. But here you can see this is for 3D. When you work with 3D, vxi plus vyj plus vzk. Okay, this is actually a long formula, but you could see that the only thing that you see adding there is this one. But and then if you want to get the magnitude of a 2D, this is where you have a magnitude. And in order to solve for the magnitude, this is what you see you use in 2D. So vx squared plus vy squared square root. But if it was in 3D, you would have something like this. It should be just similar to what you got there. But instead, we're going to add vz squared. So this is what you got in 3D in order to get your magnitude. Okay, and just to give you an idea, since we use vx, vy, vz, now you have a question: what is vx? What is vy? What is vz? And the representation of vx, this is what you see: v cos theta, y v sin theta. When you work with 2D, so 2 dimension. So this is a case of 2D, 2 dimension. So we have vx and vy, and this is the resultant. Imagine it could be something like this. This way we have y, and then this is where we got x. So, and this is the center. Okay, and then this is a 2D, and then from this 2D, vx, it's the vector cos v cos theta, v sin theta. That's why you see vx here. We just represent it in using that formula. Vy equal to v sin o. That's why you see we have v sin o there. Okay. Now, what you see here, this is a 3D. This section here is actually 3D. You can see z, x, y. And then you can see if in form of matrix. This is how you can represent it in the form of matrix. Okay. You can see x, y, z. The reason why we're putting 1 is where we have you find this, the rest is just 0. And then where you find y, k for z, this is where you have a connection. So this is like a matrix form, and then it's just to show you what's happening here. Z, we have k. So z, we have 1 at k, and the rest is 0. J, we got j at y, so you can see there is a connection between those two. And then x and I, so x and I, this is where you see. This is a unit vector, what you see inside. There's the presentation that we can now represent it using that. Okay, so now, in order to find this is what we use just to show you what's happening. When you have to represent it, the vector, the resultant, okay, you need to represent it into when you work with 3D. So this is where you're going to find beta, alpha, okay, and then this is where you're going to find the other symbol. So that's why you see when you go to I. So I is this one. This is where we have I. We're going to have alpha. So we're going toward alpha. So it can be v cos alpha I plus. You got this. Let me just call it this one. Should be resultant times cos beta. So when you go down like this, for toward y, this is where we have y. So this is where we have y. Okay, and this is where we have x, vx, and then this is where you will find vz. okay, and then for vz you're going to have a y there, so this is vz times k. Okay, so similar to what we did for 2D, and then we just repeat ourselves. So this is 2D, and then this one is 3D.